All right. So yeah, as just Lynn introduced, so I'm going to talk about the CORSMAL challenge and how basically we developed the CORSMAL challenge, what is the tasks, what is the data set that is used in the CORSMAL challenge, and what basically we will address specifically for the winter school here. So probably is mostly of interest for people that have already registered or for people that now would like to register after this talk. So what you just saw, let me stop also the audio. So what you just saw is basically one example of a person that is manipulating an object. Here is just a cup and, for example, pouring some content that is rice. And the goal of the challenge, of the CORSMAL challenge, is to estimate properties of the container while the container is manipulated by the person. So when we talk about properties, so here we are referring to some specific property that we identify for the challenge. So the overall challenge here, for example, is addressing different tasks, for example, estimating the type of content that is poured into a cup, or the level, for example, I don't know, is the cup empty, is the cup half full or full? The capacity estimation, so what is the capacity of this container? And we have a very different container that I will show later, some images. And this will be basically the main task that we will address through this winter school. Then overall, also the challenge address other properties, for example, the mass or the dimension of the container. And all these properties can be combined together, for example, to understand the mass of the filling, so not just the container, and then the overall mass of the object when you have both the mass of the container and the mass of the filling. So this is particularly important, especially, for example, of some talk that we heard before for human robot interaction, when the person may be pass the object to a robot that maybe assist the person for some task at home during, I don't know, during in the kitchen. So, and what we are interested here, as we saw from the video, is that the type of modality that we are considering is both video and the audio as well. So here we are in the multimodal context, as was presented before. So here, I want just to introduce basically the data set that is accompanying basically the challenge. So the data set is the CORSMAL container manipulation that consists of many audiovisual recording, in this case 1,140, and they are split between different type of container types. So we have 3 categories that we identify. So it's the drinking glass, cup, or food box. For each instance of drinking glass, so there are different type of drinking glasses or cups or food boxes, there are 84 recordings for glass and cup category, or 60 for the food box. And in total, as you can see on top, there are 15 containers, 3 filling types and 3 filling levels that we collected through this data set. And we also have multiple views. So it's not just audiovisual, but you have the vision aspect that is collected from different position. So here you have position that were collected at the side of a robot that was fixed in front of the person. We have what we call the robot view, because it was basically a camera placed on the robot, and also the body camera view. So the person was wearing also a camera, and so you can observe basically the manipulation directly from the human perspective, so from first person view. The data set is quite large in terms of recordings of images, because also we provide not only RGB but also depth images, and it was collected under different conditions. So there are different type of subjects that have been involved during the collections. There are different scenarios that I will describe more in detail later, and also we use 2 type of background and 2 illumination to challenge also a little bit the vision aspect of the data set. So as I was saying before, this is kind of the setup. So when I was talking about also there is a robot present. So when we collected the data set, we have this manipulator present here that is fixed, and a camera was placed, and the person. So here you have the 4 cameras, and also a microphone array that was collecting basically the audio produced by the manipulation of the container by the person. Here, the microphone array consists of 8 microphones that were placed in a circular configurations, and all the signal that have been collected have been synchronized all together. Also, for the camera that was worn by the person, we collect some inertial measurement data because we have calibration. So, for example, the intrinsic and extrinsic parameter of the cameras, except for the moving one. So here the calibration data can be used. Sorry, the inertial measurement data can be used for inferring basically the position and orientation of the camera. So having a closer look to the sensor. So here it was the Intel RealSense sensor that was used for the collection. And you have 2 infrared images that have been post-processed to get depth data. The dataset provide also the infrared images or infrared videos. However, for the challenge, here we ask participants to use eventually only the depth and the RGB, but not the infrared. All the images and the depth images and the RGB images are also spatially aligned directly from the sensor. Here, as I was mentioning before, in order also to have a diversity in terms of the manipulation, we involve 12 subjects in the collection of the dataset, and everybody was basically asked to manipulate the objects in a natural way. So, for example, here you can see that a lot of people use their right hand to basically starting the delivery of the object to a robot, but there are situations where the people use 2 hands, for example, or the other hand, and the grasping is different of the object. As I was saying before, we use different type of fillings. So we have the empty case. We have 3 type of filling that are water, rice, and pasta, and they have been filled, for example, at a full capacity of the container or completely full. Here also I want to highlight a little bit more when I spoke about the different background and illumination conditions. So on the top, you can see that the background was a table that was basically uniform without any covering from a tablecloth, for example. Instead, on the bottom, you can see the tablecloth. And also there is a change in the shirt that was worn by the subject in this case. And you have a different type of pattern. So here is a uniform pattern, and here is a repetitive pattern in the shirt. And also I would like to point out the different illumination. So here there was a ceiling light coming from the room, and here there was the ceiling light that was completely switched off, and there were 2 artificial lights pointing exactly to the person in this case. So here the illumination also is gonna affect how the container is gonna basically illuminate it. So I also mentioned at the beginning that we have used 3 different containers, 3 different type of scenario during the collection of the dataset. So here I will go through each of them more in detail. So for scenario 1, we have the container, for example, on the table, the person that grasps the container and shake the container, in this case is a food box, and then give the container to the robot. Also, in the case, for example, of a cup or drinking glass, the person, instead of just grasping the container, first pour a content inside the container and then grasp the container and deliver it to the robot. Here are some examples from the 4 views with different subjects of the scenario 1. So as you can see here, the container is completely visible in this type of scenario. In scenario 2, we change a little bit the condition. So in this case, the person hold the container at the beginning of the sequence and then pour the content into the container before delivering to the robot, or in the other case, shakes the container and then deliver the container to to the robot. So now to move to the last scenario that also is part of the data set. Basically, the person is standing a bit outside of the area, so not just in front of the robot. He pour or shake, for example, the container, and then walk towards the table before attempting to deliver the container to the robot. So in all these scenarios, I always mention that the person is delivering the container to the robot. In reality, what happens is that the robot doesn't move. So basically, just an attempt is at the start of delivering the container to the robot. So here are final example for the scenario 3. As you can see on the top left, for example, the person is shaking the container before moving towards the table. So in summary, here are the 3 scenarios where what the goal is to increase basically the challenges happening in terms of occlusion, entering field of view, and the human dynamics, and also to challenge a little bit the audio, for example, in terms of distance from the microphone and the type of sound that is heard. There are also some background noise for the audio aspect. And also I would like to point out, just holding a container, grasping it, shaking it, or give the container standing and sitting. So now here are the containers that are provided with the dataset, and especially for the winter school, we are focusing on the training set. So we have 9 types of containers. As you can see here, we have the cups, the glasses, the drinking glasses, and the food boxes. So in total, there are 684 audiovisual recordings, and this is the only data that will be used during the winter school challenge. So for the challenge, I will ask participants to split the data according to the type of container under 3 different setups, and split into for the training and testing set. So here is the first setup, and I highlight in black the container that has been used that should be used in training and the one in testing. So which of the recording belonging to that specific container. Here is the setup number 2 or 1, as I pointed here, and the setup number 2. So there are a holdout of the containers from the set, and there is a holdout of each, for example, cup, glass, or food box. So basically, I would invite also the participants to take a close look to this. I will give also this slide later so people know what they have to work on specifically. So in terms of evaluation, we will basically evaluate quantitatively the solution in terms of average capacity score. So the task is to estimate the capacity of a container across different configuration, the scenarios and type of containers. All the data set is basically already shuffled, so it's just a matter of selecting the container to use for training and testing. And basically through this, we will compute the average of the relative error that there is between the estimated capacity and the ground truth. So J here is the number configuration, and also participant don't in case the solution fails to estimate basically one value, basically that will not be taken into account as an error, so the error will be put to 0 and average across all the configurations. We are providing an evaluation toolkit where there is this performance score computed, and you can use it to basically estimate what is the average capacity score for your own results, and we use it basically for rank the teams. The evaluation also has been not completely only delivered by the performance score, so this is gonna account for the 50% of the full evaluation, but there will also be a panel of judges that will take into account the creativity and innovation of the solution, the quality of the presentation, and the distribution of workload across team members if a team consists of more than one person. So in terms of what team need to submit, they will have to submit a PDF because there will be a presentation on Friday of their solution. They will provide also the estimated results on the free test sets, and also an unlisted video of maximum 5 minutes to show how the code is running, and basically that shows that the code is running, that has been developed. I would like to remind that the submission deadline will be on Friday at 11:30 our current time here in UK, so GMT or UTC 0. And this submission should be done to my email address that you can see here. Just a couple of information. There is a template for the presentation. I provide here the link, and is available also at the CORSMAL Challenge Evaluation Toolkit. We will allow a maximum duration of 5 minutes. And also we would like that the presentation focus on some specific aspect of the solutions that goes from what are the modality used, what type of tools have you already employed, and where is the, for example, your novel idea, the hardware that you use for the experiments, the roles that the team in the project have in the development of the solution, and also possibly when you develop a multi-model solution, what is the advantage compared to the unimodal baseline that you choose in that case. Just the last final bit of logistics. So today at 3 p.m. after the question and answer, we will finalize the teams. The challenge will begin. I would like to ask that each team will communicate a name and a corresponding person by 5 p.m. Tomorrow and on Thursday, there is a Zoom slot at 1 a.m. At 11 a.m. If you have any question to ask, we'll be available to provide answers. If you cannot make it, feel free to drop me an email in case. And then just remember to submit at 11:30 on Friday your results, and we will have the presentation just after at 1 p.m. So that's it from my side. So for all people that have already registered to the team, to the challenge, good luck. Let's make the challenge starting, and whoever else want to register, please feel free to do it. Thank you.